this will be the very last lesson of chapter 9. We are going to be done with significance tests. We are actually done. In 9.1, we did talked about some terms like what do we mean by hypothesis, how do we write the null versus null alternative. And in 9.2, we did significance test about population proportions. And in 9.3, we did significance test about population mean. And those, when we had to find the test statistics using all the formulas, that's when it kind of got a little mathy. We had to use a formula, the z-score formula and everything. But I did also show you how to use StatCrunch to find some of them, and using the normal calculator or T calculator to find sometimes the p-value, or sometimes the backward. We were given p-values and had to find the test statistics that correspond to that p-value. And we talked about everything, and I was just checking. What was I checking? Sorry, I got so many tabs open right now. But I was just checking MVCC Math 245. You know, with everything happening, and the fact that I have to give you your very last exam next week, we just wanted to make sure that we covered everything in the inference section. And looks like I've read through these lists. Univariate statistical inference, that's what chapter 9 and chapter 8 and 9 was all about. We are done with the descriptive, sampling, and probability concepts. We started chapter 8 and we're finishing chapter 9 now. We're done with univariate statistical inference, creating or making confidence intervals and conducting hypothesis tests. But there was one thing that I never really did, which was describing type 1 and type 2 errors. So I am going to go over 9.4 so that we can make sure to cover this very topic, describing type 1 error and type 2 errors in the context of specific hypothesis test. So chapter 8 and 9 are the big part of the inference section. And we'll come back, and because I technically have 1 3-hour left with you to teach this, I'm going to go over the 2 sample statistical inference and the correlation regression. It looks a lot, but I'll try to do this in a condensed 3-hour lesson so that, but I will never put anything that I don't go over on your exam 3, so do not worry. I will pick your exam 3 problems, and I'll make it on my math lab again, from the previous homework problems that you already tried for me. Okay, so we're good with covering the course objectives. You will just be a little busy, but let's go over 9.4, decisions and types of errors in significance test. So this is kind of short, just about 13 slides. And then I will have week 12 homework, which is already open for you. Just double checking. Yes, so week 12 homework. So today is week 13. I'm actually recording this on May 1st. But then I remember that I extended the homework. And there was only like, I think, 2 problems of 9.4 on the homework. So I think you are okay. But week 12 homework is due Sunday night, May 3rd, instead of Thursday. With me having some technical difficulties in the beginning of the last week, I couldn't upload the lessons on time for you. I only had like parts of it. So I extended the due dates on this homework, week 12 homework. Week 13 homework, I'll have a couple problems from chapter 10 and chapter 3. And then I will also have an optional practice test available for you so that you can prepare for your exam 3. I know you will be busy in the next week, but you are going to be done with this class next Friday. Did you know that your final exam is actually next Friday? Just it just happened so quick. May 8th is your final exam. So I will have May 1st today to kind of add a couple more lessons, and then I will ask you to take your very last exam. And thank goodness it's not going to be a cumulative exam. It's just going to be the materials that we covered in chapter 8, 9, and a little bit of 10 and a little bit of 10. I'll try to keep it to chapter 8 and 9 mostly because those are the things that we learned in the last 2 weeks. Okay? All right. Let's go back to 9.4. Now all the lessons are posted there. I'm just gonna go ahead and finish this video and then have a link also up there for you. And these slides are also accessible by going to the modules and clicking on the agenda, okay? All right, 9.4 note is posted on Canvas for you too. It's pretty short. That's something that we should definitely talk about. All right, let's go ahead and start. Let's review p-value and significance test alpha a little bit. Significance level, 0.05, alpha equals 0.05 is the most common in practice. So if it doesn't say it, we're just going to assume that you are using 0.05. But I want you to always list that significance level in the beginning of your test, because we're going to create bias if we decide on the significance test level after looking at the p-value. So we shouldn't do that. We always want to set the alpha level first. The most common one is 0.05, but if you want to be strict, you can say, oh, I want it to be 1%. Okay? All right, so what happened? We compare the p-value, right? The probability of such event happening to that alpha level. And if we get something like, oh, we got the result that's saying that it's probably like 1% chance this thing will happen if the null hypothesis is true, then what we're going to say is, because this p-value came out so small, it's highly unlikely for that thing to happen, then we're going to say we have a strong evidence that the null hypothesis is not true. Therefore, we will reject that null hypothesis H0 and then go with HA, the alternative. And that is what we want. That is what we want. A smaller p-value indicates stronger evidence against the H0. And that's what we want. We want to reject the H0, the null hypothesis, so that we can believe the alternative. Now, if the p-value comes out a little too big, that means, well, it may have just happened by chance, because there's like a 7% chance that this happened. And you know, the alpha level is that the number that you're going to compare to. If your number was 0.05, 5%, and you're going to say, if it's less than 5%, I'm going to say that it is statistically significant and reject the null. If you get a number that is greater than 5%, then, you know, we just have to say, hey, I don't have strong evidence. I'm going to have to say that I failed to reject the null. But here's the thing, though. Failing to reject the null hypothesis is not the same thing as accepting it is true. Okay, it's like, I failed. Oh, okay. So the smaller alpha, the smaller the significance level is, it will be more difficult for you to reject the null, right? Because your standard, your expectation is so low, it will be even more difficult to get at the actual p-value even smaller than that. So the smaller the alpha is, the stronger the evidence must be to reject null. So if your alpha level is, say, like 1%, then your p-value needs to come out to be less than 1% or equal to 1% for you to reject the null. So to avoid bias, we select alpha before looking at the data. Say that you say that you got a very strict standard, let's say, and you say, you know what, I want my alpha level to be 1%. And then you did your test. You did your p-value and everything, and your p-value comes out to be, say, like 3%. And you're thinking, uh-oh, 3 is bigger than 1%, my original standard. Can I go ahead and just change my alpha to 0.055% so that I can say I reject the null? We can't do that. That will be creating, so to be fair, to avoid bias, I want you to select that alpha level before actually getting the p-value, okay? And the most common one is 0.05, okay? So here's the thing though, just because here's how I explained it, right? I said, it is highly unlikely for such a thing to happen, therefore I don't believe it. And that's the significance test. The probability of such event happening is so low, I don't believe that the null is true. So, but then the thing is, things like this may happen. Maybe Sue may go out tomorrow and buy a Powerball and actually win it. What is the probability of me winning the Powerball tomorrow? Seriously, guys, it's definitely less than 5%. It's probably less than 1%, right? But it doesn't mean it's not going to happen, right? Who knows? So the thing is, just because something has a very small chance of happening doesn't mean it's not going to happen. So what if it was highly unlikely, but it actually did happen? And the null was actually true? That means, you know what, because of those small chances, small probabilities of such events happening, we may have made a mistake. Maybe we shouldn't have rejected the null that Sue's not going to win the Powerball tomorrow. Um, because of sampling variability, and the sampling variability in my example was a little Sue winning that Powerball with such a small chance. If I sample me and I win that Powerball tomorrow, then our test, our null that where we rejected that she's going to win millions of dollars is incorrect because of sampling variability. Decisions in significance has always have some uncertainty. And you notice when we do a significance test, less than 5%, like the more common significance level of 0.05, that's when we reject, right? So we actually have a 0.05, 5% chance of rejecting when we really shouldn't reject. So this can be an error. So errors can happen when we do significance tests. And they don't really have fancy names. Tests have two types of potential errors. The first one is just called type 1 error, and the type 2 error is the second one. They don't really have a fancy name, just type 1 and type 2 error. So what we need to do, as listed in our course objective, what I need to do today is I just want to talk about, I need to describe what type 1 and type 2 errors are in the context of a specific hypothesis test. I'll give you some examples, but we'll also look at, hopefully I get to look at those examples in context. All right, so you know that things can go wrong in a significance test, and we may have type 1 error or type 2 error. We know that now. Now let me go ahead and talk about what they are, okay? And then I'll give you some examples. Type 1 error happens when H naught is true. When the null is true, when the null hypothesis is true. Should we reject it? No, we shouldn't reject it, right? When the null hypothesis is true, we better believe it. We better accept that it is true and then stay with it. But type 1 error happens when we reject that true null hypothesis, okay? When something is true, you need to believe it. But if we accidentally reject it, then that's what we call type 1 error. Now the other way around, suppose that the null is false. Now if something is false, what should you do? You should reject it. You should move on to something else. If someone is wrong for you, then you need to move on. But type 2 error happens when we fail to reject it and we stay around with it, right? So these are slightly, you see how they're different? And it can be kind of confusing if you don't do this every day, right? But I know that the notes are there for you. I'm going to do my best to kind of explain the difference between them. But that's basically what they are. Type 1 error occurs when H naught is rejected when it shouldn't be rejected because it is true. Type 2 error occurs when H naught is not rejected, but it should be rejected because it was false. So that's the slight difference. And here's my example for you. I think I showed you a picture like this on 9.1, but now it's time for us to talk about it. Now, type 1 error is like a false positive. Now, if you just look at the picture, and I added these yellow parts myself, if you look at this case on the left, this gentleman sitting there, look at his expression. That's a good picture. And this doctor's saying, hey, you're pregnant. And that's false positive, right? I don't think he's pregnant. He doesn't look pregnant. Yeah, I don't think he's pregnant. So here's a null. The patient is not pregnant. That's true. The patient is not pregnant. So what we should do is we should believe this null hypothesis. But what's the doctor doing? The doctor is rejecting this, right? He's saying the patient is not pregnant is false positive, and saying that the alternative, hey, you're pregnant, that's true. Because he is not pregnant, this gentleman is not pregnant, we need to fail to reject this null. And that wording is so confusing, and I hate to use this wording, but we need to accept that he's not pregnant, right? Because in fact, this guy is not pregnant, but the false positive will make us believe the otherwise. Therefore, that is an example of type 1 error, and in other way of saying it, that's like having a false positive here. Now, what about type 2 error? Take a look at this. What's the null hypothesis? Well, let's say that the null hypothesis that she's not pregnant. Well, is that true or false? That is false, right? The null hypothesis is false because she is actually pregnant. So we need to reject this null. But what is the doctor doing? She is believing the null hypothesis. She's staying with that null hypothesis. We need to reject this null and believe, is that how I spelled it? I don't think so. Believe that the alternative, pregnancy, is true because in fact she is pregnant. But you see how these doctors are making a different mistake, right? And it depends on whether the null hypothesis is true or false. Okay? So two types of errors and four possible results from a decision in a significance test. So let's go ahead and organize this table together. So suppose that first, that H naught is true. If the null is true, you better believe it. Okay? So we should not reject it. If it's true, we should not reject it. So that's a correct decision. That's what we want, right? But you know what? We may make a mistake. If null is true, if that's a true statement, and what if we reject it? That's gonna be a type 1 error right there. So those two things can happen when null hypothesis is true. What if the null hypothesis is false, and then you do not reject it? Well, that's gonna be type 2 error. And what we want, the last one, if the null is false and we reject it, that's the way to go, right? If it's false, if it's wrong for you, then you need to reject it. Then that's going to be the correct decision. So these four things can happen. And I think it may be a little bit confusing, but don't worry, you got your notes when you're doing your homework problems and actually your exam 3 too. But just got to remember the difference between type 1 error and type 2 error, and those are just based on the fact that whether the null hypothesis is true or false. Let me read this. Type 1 and type 2 errors are the two possible incorrect decisions. A type 1 error, false positive, occurs if we reject the null when it is actually true. A type 2 error, false negative, occurs if we do not reject the null when it is actually false. We make a correct decision if we do not reject null when it is true, or if we reject it when it is false. So that was a very loaded sentence, really, a paragraph. I talked about 4 cases, but if you just take it slow and then read it, they all make sense, right? They kind of make sense. All right, so look at another one. Decisions errors in a legal trial. Say that the null hypothesis, remember, is that defendant is always innocent. Okay, so and the alternative is actually rejecting that he's innocent and believing that he is guilty. And it's somebody's job to do that, right? Type 1 error happens when we convict a defendant who is actually innocent. Oh, that will be bad. I didn't do anything wrong, but then I got convicted. That's an error, right? So when null is true, when the defendant is actually innocent, we shouldn't be convicting that person, right? So an error happens when we convict that innocent. So what's the result going to be? Well, the result is really sending an innocent person to jail. Oh, that's horrible, right? That's horrible. Type 2 error. What's type 2 error? Acquitting a defendant who is actually guilty. Oh, so if somebody actually committed a murder and we accidentally let him go, that's another type of error, right? So the result will be setting free a guilty man, and that's also bad, right? Someone did a crime, they should pay for it, but we made a type 2 error, so we're letting him go. But think about it. What's really worse though? What is worse? You think about it. What's really worse? Sending an innocent person to jail, or setting free a guilty person? So possible result, and I didn't really make this a fill-in, but very similar to that previous table with 4 cases, right? So if a defendant is innocent, then the correct decision is to acquit. We will be making a type 1 error if we convict that innocent person. But in another scenario, what if that person is actually guilty of committing that crime? Well, the type 2 error happens if we let that man go free. The correct decision will be when we convict that person and send him to jail or prison. Okay, so that's the 4 possible results of a legal trial. The probability of rejecting that H naught, even though it is actually true, is actually equal to the significance level, right? Because that significance level was, like, the common one that we said was like what, 5%, and we say if it's less than 5%, I will just go ahead and believe that it is statistically significant for us to believe that it's unlikely for such event to happen. So, probability of rejecting H naught is the same thing as the significance level. Because we're rejecting if it's less than 5% or equal to 5%, and that's the chance that we may be wrong, right? When the significance level is 0.05, the probability of incorrectly rejecting H naught, committing a type 1 error, is actually 5%. So if somebody asks you, hey, what's the probability that you just made a type 1 error? I'll say that's the same as my significance level, 0.05, 5%. In practice, we don't know if a decision is correct. I mean, a lot of these legal trials, we don't know if he actually committed a crime. We don't know. We may have an idea, but a lot of times we just really don't know the truth. However, we can control the probability of an incorrect decision. We can at least control that probability. We can lower the probability of certain incorrect decision versus the other type of incorrect decision. And by playing with this, maybe the significance level. So here you go. When we make a decision, so here's the things. You're like, we should never let go of a guilty man free. If that's your statement, we may consider this. When we make a decision, why don't we use an extremely small probability of type 1 error, such as alpha equals 0.000001? Say that your standard is, I hate to say low for a low number, but that's like a very high expectation for a strong evidence, right? For instance, why don't we make it almost impossible to convict someone who is really innocent? That sounds like a good idea, don't you think? If somebody's innocent, we better make it very, very impossible to convict that person. But here's the thing though, like remember, in practice, we don't know if a decision is correct. We don't know if we think he's really innocent, but is she really innocent? We don't know that, right? So can we make it almost impossible to convict somebody? Well, if we tolerate only a, what's that, n extremely, only an, okay, sorry. Hello, I see somebody in here. Anonymous Arok. What is that? Okay, so the Google, they just name by some random animals. Okay, you're probably wondering, where's the video at? Sorry, I'm in it right now. Okay. If we tolerate only an extremely small chance of type 1 error, such as alpha, making that alpha level so small so that it is impossible, is very, very difficult to reject the null, then the test may be unlikely to reject the null hypothesis even if it is false. For instance, it's unlikely to convict someone even if they are guilty. In fact, some of our laws are set up to make type 1 errors very unlikely. And my goodness, I'm sorry. And as a consequence, some truly guilty individuals are not punished for their crimes. And don't we see that very often? I mean, but we know that he did it, but he goes free. Because our laws are set up so that it's difficult for us to send an innocent person to jail. Because, as you know, these are going to be inversely proportional. And we'll talk about that here. As the probability of type 1 error goes down, the probability of type 2 error goes up. And also the other way around is true. Because these two probabilities are inversely related. If you set your standards so high, well then it's going to be impossible for you to convict anybody. And you may be letting go some of the, you may be freeing some of the guilty people, guilty person. And if you make it so easy to convict everybody, then you may be accidentally putting some innocent people in jail or prison, right? So these are inversely related. So we just have to. Now, did we talk about it? And we just gotta know that. I guess we need to compromise as we want to be high and want to be low. But that's really it for 9.4. Just kind of like a story time, right? It was fun. But we did finish univariate inference. We did confidence interval and significance test, and that is 2/3 of your exam. Okay, that's going to be a 2/3 of your exam. The last third, I'm going to go over them this week with you. Um, since you guys are still kind of finishing up your 9 this week by Sunday, I'll make sure to have everything posted this weekend for chapter 10 and chapter 3, a little bit of each, and have a practice test open for your exam 3 too, okay? All right, I'll see you very soon.